Hello, everyone. Good morning, evening, afternoon. I would like to welcome you all to first ever Hypertrace community call. I'm Jayesh Aive, and I have been working on Hypertrace since quite some time now and worked on engineering, product, marketing, most of the aspects around it. So, as you are here, you probably know what Hypertrace is and uh, how it works, but I will just go over the brief overview and where we stand today, and we can then discuss in details around the new features we have, and we have few demos planned as well. So Hypertrace is real-time distributed tracing and observability platform that helps team make sense of their production request and basically trends in the network. So Hypertrace converts distributed traces into relevant insights for everyone. So infrastructure teams can identify which services are causing overload on the operations. So application teams can understand which requests put their service objectives at risk. Or maybe deployment teams can identify if the new version is causing some issues in their application. So Hypertrace accepts all the major tracing formats, so tracing standard formats like zip, Jaeger, and OpenTelemetry. So if you have your application already instrumented for distributed tracing, you are good to go with Hypertrace out of the box. So we created Hypertrace at Traceable and open source it, and now community and our probably happy users are helping us to make it a best observability and tracing platform out there. So agenda for today briefly involves going over the current state of Hypertrace, then engineering updates for latest point 2 version we released yesterday, and a demo of some interesting features we have added in point 2 release. Then we will also briefly touch on the roadmap or what are some of the interesting features we are planning to implement in next few quarters, and we will at the end we will get some open questions around observability and tracing and Hypertrace. And an important announcement: if you survive the complete call, you also have a chance to win some cool Hypertrace tracks. So first and most important question: why Hypertrace? So where we stand today and why you should probably choose this tool. So we provide some unique features on top of distributed tracing data we collect. So we have topology, which is a service graph, and it's for services and backends, and it works in real time. It's scalable for hundreds of them. We provide pre-canned dashboards for services, APIs, and backends, which might be the one thing any service owner or any API owner or backend owner might need. And we provide extensibility, so you can write your own indicators to trace data with different attributes, maybe your business data according to your business needs, and you can even surface that information in the platform. So if you want to slice and dice on that information, you can do that. It's interoperable, so Hypertrace works out of the box with all the standard tracing formats like Zipkin, OpenTelemetry, and Jaeger. We and everything is built around GraphQL APIs. So we have traces, spans, entities exposed via GraphQL APIs. So you can build your next creative use case with it and play around with the data. So and we provide API and trace analytics. So we have a powerful slice and dice screen called Explorer. You can slice and dice on endpoint traces, or you can slice and dice on span data from there, and that's powered by Apache Kino. The new interesting features we have added recently are span logs and AI analytics. Span logs help you to help you in doing better RCA and reducing MTTD for identifying issues in your system or applications. And error analytics helps you. Error analytics basically highlights errors and helps you identify those issues quickly. And again, speeds up the RCA itself. So looking at the overall current state of Hypertrace, we support two types of major deployments. You can get started with Docker Compose deployment, which is a quick start way to deploy, and it basically helps user to try out product and try out features and decide if they want to go with it. Then we support Kubernetes, and our Helm charts are available in the main repository. So you can deploy Hypertrace in any Kubernetes environment. So if you want to deploy in ECS or EKS or GKE or AKS, even on raw EC2 instances or VMs, you're good to go. In case of compatibility or data collection, as I mentioned before, so we support all the major tracing data formats like Zipkin, Jaeger, and OpenTelemetry out of the box. And if you have your application instrumented for OpenTelemetry or Jaeger or even Zipkin, you can just plug Hypertrace and start using it. Sorry. So the one thing we call language modules or agents specifically, we have written our own Java agent, Go agent, and Python agent on top of OpenTelemetry agents. And if you Java agent and Python agent are auto-instrumented. So if you want to auto-instrument your applications, you can use those agents as well. And we even are compatible, as I said, we even are compatible with OpenTelemetry agents and modules. So if you want to use those, you're free to use those, and you can still use Hypertrace. Cool. Enough around the overview and the current state around Hypertrace, and I will hand it over to Onak, who will give you some engineering updates and what are the interesting things we have built over last month. And yes, then we will have some demos from JC, Vishab, and Sandeep, even Ronak, who have helped us build these features. Thanks. Over to you, Ronak.
Thanks, Jayesh, and hello, everyone. So if you are a first time coming here, or if you're already using Hypertrace, then this will be update for you. And if you are a first time, then check out our previous release note to get the update. But as part of this update, we are, as this is the first of our first community call, we are likely to cover the updates based on our past major release and what are the improvements gone based from the previous release. So as part of them from the last list, these are the few improvements we added over a couple of past couple of 2-3 months. So recently we added the support for embedded log events. So what is as Jayesh already explained to you, it is a span log. So now you can ingest any log events associated with the spans. So, and they are timestamp based with respect to the span duration. So now with this enriched data along with the spans, it will help you the more deeper analysis and pinpoint the issues in your operation failure or root cause analysis. And so if you're already using Jaeger or OpenTelemetry SDK, you can use the API code log fields, or if you're using telemetry, you can use add events to ingest the data. And the Hypertrace supports will support the ingestion of those data, and you can able to visualize those things. We also added the support for the error analytics. So all the open tracing specification supports for indicating failure in the spans. So in the previous release, you were able to find out this detail using the Explorer query. But recently we added the numerical support for this data set, so that you can better slice and dice and the play around with this, that how many errors are there within a given operations or within a given trace. With this, across all the trace, across all the collection of traces, and prepare the error traces and do the slice and dice and further analysis. And both the Jaeger and so we utilize the information, both the Jaeger and OpenTelemetry provide some kind of conventions for identifying this specification. What are the spans are error spans. So that is the enhancement we have done, and that we will cover in the demo as well. Recently, we also added the support for exporting a trace. So now you can download the trace from the Hypertrace UI in a JSON format, which is out of the box the OTLP JSON format. And so you can re-ingest the data. It can be used for multi-purpose. It can be used for debugging. You can replay for one environment to another environment just to understand that why some service is not visible or something, or it can be used for support ticket and to identify the issues. And as Jayesh already mentioned in the earlier, we added one more agent in our offering as a part of continuously enhancing our instrumentation stacks and making it easy for trace data collections. So that JC will cover more detailed depth and give the demo on these things. We also recently enhanced our API trace analytics by enriching in the exit call related data. So this newer information, like given one single operation, how many one specific API call when you are making or making outgoing call, that can help you to identify non-trivial optimization or bottleneck issue that you might have coded, but it is not visible very easy with the ease. So you might identify and finding, okay, one given API trace, how many exit calls they are making. So if you're making like 100 or such, then you can easily see that, oh, there is something bad going on. On top of that, and apart from this last release, on a previous release, we have done some improvement related to backend entity improvement. Here we added the more backend identifying support for more backend like Cassandra, Elasticsearch, AWS SQS, and Kafka. We also made some of the field related to backend as a first class field, like operation data and destination. So those field help you a quicker analysis of finding a slow query or issue related to your backend system. Recently, we have done some optimization work as a part of our ingestion pipeline. This that has helped us to improve our support for large traces. So you can increase your max span counts with certain limit with the same reasonable resource constraints. So these are the some improvement has gone in the this current release compared to the last major release. Yeah. So there is an overall high level update for this month from engineering side. I think we'll see these things in some of this important thing like first 5 things as a part of the demo now.
Cool. Thanks, Sonak. And yes, so enough talk, I guess. We will move to demo and then see everything in action. So first we have Hypertrace Python agent demo by our own JC. So JC, you want to go with it?
Yes. Hi, everyone. I will share my screen. I think, Jayesh, you need to stop sharing.
Yes.
Okay. Yes. So hi, everyone. I'm Jose Carlos. I'm maintainer for Hypertrace Go agent on Python agent. Just a brief, a few lines about Python agent. It's a library. It's a repository containing the instrumentation for Python applications. As of now, we support both initializing the library in the application or auto instrumentation as ultimate mean for instrumentation. We support many popular frameworks or libraries in Python: Flask, gRPC, MySQL connector, Postgres, Request, AIO, HTTP. As I mentioned it, there are 2 ways to run instrumentation here. One is initializing the agent in line in the code, or using auto instrumentation, which is merely adding the agent as a dependency and then using our CLI for running the instrumented app. In this specific case, I will run one of the examples, or actually a couple of examples in Python agents, because we provide examples so people can try it out. For that, I already have running Hypertrace to save you time. And then I am already in the repository. This is the CLI. On top left is for the client, and then we have the server. I'm gonna do make run for the server. But before I run this, let me tell you that the server runs a Flask server that does connect to MySQL server, to MySQL database. So let me run MySQL and then run the Flask application. And then on top, I have a client, which is, I can actually show you the code, but it's a basic client using requests, AIO, HTTP. This is the way we initialize the agent in code. We initialize the agent and then we register what framework we want to instrument. Okay, I have the server on the left bottom up and running. As I said, it's a Flask application. You can see it here. It's just a Flask application. We initialize here both Flask and MySQL. Later on, I will show you the auto instrumentation example. But basically, it does register a user. That's it. We have a very basic configuration where we say what is the server name. It's file configuration. So we pass a file, and then in the environment variables, we say what the file it is. Propagation formats that are supported, and then the reporting, which is we're using Sitkin Reporter. So yeah, we have the server up and running, and let's run the client. Okay, the client called the server. The server received the request and did some MySQL magic. And then we will go into Hypertrace into services, and we say, tada, the client and the server, right? If we look at the client, we will see that, oh, my screen is too small. Okay, we have P99 latency. We have different percentiles for latency. We have metrics. We have this distribution graph. And we also have a dependency graph for the client application, right? It's called a backend, which is localhost. Or sorry, a service, which is called localhost 9000. If we go to endpoints, if we go to traces, interesting. We don't have traces, yeah. And I think that's expected because we are looking at the client. If we go to server, we go to trace and we will see an HTTP post. The client did a call to the server. Actually, we can see that in the application flow that I didn't show it to you. Okay, this is interesting. Client is calling localhost 9000, and then server is localhost 9000, but I think I didn't somehow match this with this. Okay, let me show you the trace. We go to traces, we see the HTTP post because server received a post, and we see that inside of the span, we have a MySQL span. First, let me show you the HTTP span. We have most of the HTTP information method and the receiving host. We have what was the request body, which is something very owned by Hypertrace. That's a very own feature from Hypertrace that we record bodies for requests and response, as you can see here. Right, and we record also all the request headers and the response headers, right? So you can get more data collection. If we go to the MySQL span, you will see that we have the database name, the statement, what was the system, the user, and then what was the address for the MySQL user. So sorry, the MySQL database. If we see the full trace, we will see that the client called the server, the client did a post request to the server, and then the post request ended up in a MySQL call, right? So yeah, that's basically the instrumentation for a client server scenario. Let me stop this, and we go into auto instrumentation. Let me actually show you how it looked like, the code for this. We basically have a Flask app, like any other Flask app, nothing special, nothing more than whatever you will do in an application. We of course have the requirements of txt, and then assume this is the Hypertrace Python agent. Since we are in the same folder, we call it in a relative path. But yeah, this is the Hypertrace Python agent. So the only thing we have to do is to include this into the in the dependencies, in the requirements.txt. And then whenever we run the application, and this is the other important part, we say, okay, this is the config file we are passing, which is the config.yml, which is a standard config file, right? With the service name, the propagation formats reporting. Actually, service name is good enough to run. And then we say, okay, we pass the CLI, or we use the CLI, and then we pass these Python commands. So basically, in let's say, before Hypertrace, you will do something like this, right? After Hypertrace, you will just do this. You pass the environment variables, whatever you want, because you can also override config through environment variables, and the Hypertrace instrument, which is the CLI, right? But as you can see in the code, it doesn't mention anything about Hypertrace. We don't do anything about it. We don't mention it. We don't include it. Nothing. And then if we do the make run, actually, I will do the core. I will call the port 9000. As you can see, we are running this Flask application in 9000. So let's do this, and then we get hello world today is, and this is the date, right? Let's see how it looked like in the Hypertrace world. But let's give it a second, and then the app, which is let me show you. If we cut cut config, you will see that we call it app, right? Service name app, and this is the service name. So if we go to traces, we will see one trace. It was a 200, as you could see here, right? It was a 200. We get into this. Internally, again, it records everything as we had previously. And this is the user agent, as you can see. So we also record headers. And then we have a call to the database, right? Where we select the current date. That's the actual date that we are displaying here. And of course, this is an example, right? It will be much more complex in your usual applications. But this is just to demonstrate you how you would run in onto instrumentation mode this library. Originally, it instruments all the supported libraries, but you can opt in or opt out, or actually, yeah, opt in or opt out specific libraries. As you can see here, you can say HT instrumented modules. You can say what is it, Flask, MySQL, Postgres. You can decide whatever you want to instrument and what you don't want to instrument. So yeah, that's mainly it. Python agent is built on top of OpenTelemetry, though we guarantee retrocompatibility. So if OpenTelemetry introduces a breaking change because it's still in under development, we will try to not to propagate that to you. So it's safe to use it in production as of now, and you won't expect like huge changes or massive refactors. And yeah, it's open sourced under Apache license. So this is what it is for Python agent. You can ping us on a Slack room, or open an issue or whatever if you have any question. So thank you.
Thank you. So we will move to and thanks, Jesse. It was like very interesting, and I hope people will find it very useful. So we will move to the next one. Next demo is from Rishabh on span logs and how we expose them. We can use them in our platform. So Rishabh, over to you.
Hey, hi everyone. This is Rishabh. I'm also a contributor to the Hypertrace platform. So yeah, I mean, as already covered in the previous slides by Ronak and Jayesh, we have added the support for this feature called log events. So along with these spans, we now also surface the associated log events, if there were any, in the scope of that span in our platform, along with the traces. So log events are especially helpful in trying when debugging issues, performance issues or root cause analysis, and they help you answer the why of the problem, right? You can see matrix, you can see spans to understand what happened, but the why of it is often that we want to solve through these monitoring platforms. So for example, say the latency of some API was very high, right? So you get that information surfaced, but to find out the why, the log events that actually happened in the application at that time is really helpful in answering those questions. Or for example, some API has failed, error route. What was the reason? So the log events are really helpful in finding out that answer. So let's go over and see this in action. So this is the Hypertrace platform. So we are currently monitoring the classic hot rod application. So I guess most of us will be familiar with the architecture. So yeah. So let's say I'm the owner of one of these services, say driver service. So let's go over and say I'm seeing some issues in driver service through some alert manager. So this is the dashboard of the driver service. And then here I get some overview about it. And then I have some other information. So for example, let's go to traces. So basically these are called API traces in our platform. These are basically, the subset of the traces starting from this driver service onwards. So the API which was called here was, as you can see in most of these traces, is the find nearest API. So what I'll do is sort these APIs based on their latency, right? Let's say, so all of these APIs are taking some time. Let's say I want to debug why the first API is taking the maximum duration. So I click on this, and this is the subsection of the large trace. If I want to see the full trace for this operation, I could just click over here and see it. Yeah. So this was that operation which took 242 milliseconds, and it's relatively high compared to the other operations. So if I click over here, yeah, so I can see some log events. And if I say go back, again, okay, let's probably, I think, so this is a test application. So probably not all the log events are very indicative of the real problem. Let's look at some other service. Let's say take this route service. And here again, some APIs are being called. Let's try to see. So again, if you see, there are log events associated with every API call. And these log events are quite often, helpful in understanding what the problem was, they might be reflective of. This is a test application, so it might not be, a good representation of what actually happened. Yeah. So this is it about the log events. We'll move over to the next feature. This is called exit calls for endpoint traces. So we take a API first approach in our Hypertrace platform. So exit calls are basically the number of outbound calls that an API is making. So basically all the upstream calls that an API is making, we try to list it out along with the API traces, and we also provide a breakup of this information. So let's go over to the Hypertrace platform and see how this is in action. One reason for surfacing this information is it helps you find out the bottlenecks in your pipeline. So say some API is having a large number of outbound calls. there is a need to see its design. Why such a high fan out is existing in the architecture is a question, probably. So typically what you will do is, go to the Explorer and try to see if, like, find out the APIs which are having exit call greater than, say, some value. So if you see here, these are all the different APIs for different services, and this column lists the exit calls being made by these APIs. If you hover over it, you can see a breakup of that data. So for example, this API is making 10 calls to a upstream service called route, 1 call to upstream service called driver, 1 call to customer. If I click over it, I can see here the detailed breakup. So probably here we can try to find out why 10 calls, are being made by this dispatch call to the same service. One other thing that you can also do is, given some service, you can find what are the APIs calling it. So for that, you would probably do something like this. Yeah. So basically, you get all the APIs which are making an call for which Redis service is an upstream, or Redis is actually a backend over here. So if you see, Redis will be, so these are the APIs which are making a call to Redis. Yeah, so I think with that, I will pause and hand it over to Jayesh.
Yeah, I just wanted to mention something. Thank you, Rishabh, for this. I think it's great. When it comes to logs, one interesting use case that we usually see is, for example, whenever you have an HTTP server framework, there is a time between you receive the request and you resolve what it, if you think about MVC, for example, model view controller, there is a time, or there is a point where you receive the request, and later in the time there is a point where you actually resolve what is the controller you're going to call, and you actually call the controller. These kind of annotations, like I received the request and I resolved the controller and I am getting into the controller, are interesting, because sometimes resolving routines because of the rejects are complex. Sometimes it uses a cache to resolve the routes. Sometimes it goes directly and iterates over all the routes and execute the rejects. This kind of time-consuming tasks or complex operations are the ones that you can easily chase down whenever you use event logs or annotations. Same for example, if you have an HTTP server that execute hooks, or after the controller resolves the response, right? There are certain tasks attached after the response. And then you can also see that by using annotations, because in the span, you will see a point in the time where the controller already finished it and already delivered the response. But then there will be a time where all these background tasks or magical tasks that was attached are being executed, and then the span finishes. So these kind of things you can infer from the usage of annotations. And there are many other use cases.
Thanks, Jesse. So before we go ahead with the next part, does anyone has any questions or anything on the demos we did right now, Python agent or span logs or exit calls? Okay, cool. So we will move to next one. Next, we have Sandeep, who will be demoing error analysis or error analytics part we implemented. Sandeep, over to you.
Yeah, thanks, Jayesh. Let me share my screen first. Let me know if you guys can see my screen.
Yes.
Okay. So hi guys, my name is Sandeep. I'm working on the Hypertrace side for like more than 2 months now. So I'm going to talk about few more features that we have implemented. One is related to error analytics. So we all know like how error analysis is important for all our applications. So we are already showing like our status in our trace tables like 200 okay and 403 forbidden, etc. But why do we need extra error analysis on that part? So, or I mean to say, why do I need to show partial errors? So I'll give the example of one analogy. So suppose we are playing a game of football and we are a team, and one of us does an error, but we won the match fortunately. Now what happens, coach comes to us and says like, one of you does this error. So why he does so? Like, he did it because he wanted us to perform well in next match so that we don't do our mistakes and it can cost us a match. So similarly, we are trying to implement the same thing here. We want to see, even if we have suppose a trace has a status of 200 okay, but we want to see whether one of the span has an error or not. So that's what the problem we are trying to solve here. So let me show you this. So I'm going to the Explorer. So it has two parts. One is in the table we can see the errors column now. So it is showing the total number of spans which contains an error for this trace. So for suppose, for example, for this trace, 0 spans are there which contains an error. So if you want to look for, like, suppose you want to look how many traces are there where uh, errors are present in this span, so we can go to API trace error span count and do greater than 0. So we can see that there are uh, some traces where we can find the error. So suppose in this particular trace we have 3 errors. So if we go to this trace, then we will be able to see in the spans, we are seeing this error icon. So this error icon plus this red span bar are the indicative of this part, like this span contains an error. So we can verify this by going to attributes where we can see error is equal to true. So this is how we are just drilling down to this feature. Like, we can say like, yeah, we know it is this, for this particular trace we have 3 spans which contains an error. So yeah, this is the first part of it. Second part is we can go to the spans tab and we can also see whether span container error or not. So this is called error count. If we go to error count greater than 0, then we can see like some spans are there which contains an error. So yeah, so these, for this feature, these two parts are there. Similarly, for this column as well, we can just sort it by the error counts and we can filter it through. Second feature I'm going to talk about is called download traces JSON. So this is already been mentioned by Ronak. Like, now we have the feature to export the trace in JSON format. So this will help us to to file a support ticket and to do a quick analysis. So suppose sometimes what happens, if I look into this good UI, then also it sometimes it gets overwhelming to find out like if like something went wrong there or not. So this looks good, but sometimes whenever the span count is long, or suppose we have 100 spans, then it will be overwhelming to find out the errors from here. So now we have the feature to export the trace. So in this, like, you can see one download icon here, where whenever we click, it will download the trace as a JSON format. So what it does, it downloads a file which is the trace id.json. So if you click on it, actually I'm sharing my Chrome, so I don't think you will be able to see this. So yeah, it opens the JSON file where you can see all the trace related information. So yeah, as I told, like, this will help us to debug and support a file ticket and re-ingest the data in different environments to check and to drill the problem, like what is going wrong, or is there some services like doing wrong. So yeah, those things we can do with it. Yeah, these two are the features that yeah, Jayesh, over to you. And if you have some questions on these, yeah. I'm open.
If you can keep sharing this, it will be good. You can just move to
Yeah.
next slide.
Yeah,
It's
sure.
just 2 slides now, so you can run with it. Cool. So thanks, Sandeep, for an interesting demo, and that covers all of the new features, new interesting features we have added, and hope you folks like it, and you will be using most of them for your daily workflows. So and then what's next? Where are we headed, and what are the different features we're adding over the next few quarters? So we are working towards adding alerting V1 in our product. Then there will be, as you have seen, we have span logs, or engine will, as Onak said, we can support ingestion of a log data in a platform. We will be building log search on top of it. Then we will be supporting application metrics in coming quarters, and we are also working towards our SaaS offering. And as a part of adding metrics to the platform, the sampling will come up as well. So this will be some of the interesting features. And as we go ahead in next few weeks, we will be trying to share more information around it, more architecture discussions and all publicly, which will be available for you to go through. And of course, you can start to trade on GitHub discussions if you have some suggestions, or if you have some issues around it. And always reach out to us on Slack, and we will be happy to discuss. So that's that's something we are building towards. Then okay, so that was sort of all from our side. So if you have any questions, we will be happy to take those now and discuss. You can find most of the resources around Hypertrace linked here. I will be sharing this presentation afterwards. So you can go to the resources, you can go to blogs, and if you haven't joined the Slack community yet, feel free to join. We even have a podcast now. You can listen to it, and we are on dev.to. We are publishing our blogs there as well. And if you want to contribute there, feel free to ping me on Slack, and I will add it to the dev organization, where you can post blogs around your experience with Hypertrace and how you are using it. Cool. So thank you, and thanks for joining in. Thanks for listening, and see you all in the next one, I guess.
Yeah. Thank you, guys.
Thanks,
Thank you,
Tej.
everyone.